Uh, we did a little bit of slope yesterday. The big takeaways were that if it was going up, then you knew it was a positive slope. No matter what. Don't need numbers, don't need anything else. Okay. If it was going down, it was a negative slope. Okay. So at least we know the sign of the slope before anything else. What did 0 look like? Don't say straight because they're all straight. But yeah, the word you want to use is horizontal. Okay. Horizontal. And then there was the one that's kind of different from all the others. Okay, and that is undefined slope. Okay. And that was vertical. How is this different from all the others? Okay, this is not a function. Good. Okay. The slope is undefined. It's not a number. Okay. Remember, we use m equals for slope, so it's weird because everything else has a number, positive, negative, or 0. This does not. Another one we're going to look at today is that the equation of this line starts with x equals. All the other equations are going to be in the format y equals mx plus b. So everything is different about a vertical line. It doesn't follow the normal rules at all. Okay. So knowing that, we did a few of these. Let's just pick one. Let's see. Any requests?
19.
On the front. 10's good one. So we have m equals for all your slopes. Make sure you do m equals. If you followed the steps I gave you yesterday, the next thing you did is you picked 2 points. Now you pick the points that are going through exactly where the grid crosses. So you can see right here is a good one. You wouldn't want to pick here, kind of in the middle, in the middle, in the middle. And you go all the way down here and you can see that's the next best line. Go ahead and, is this going to be positive or negative? Negative. So you already can see it's going down, so before you even start, you know it's going to be negative. Down how many?
7.
Down 7. And right 2. So the slope is negative 7 over 2. Now, what if I pick 2 other points on this line? What would the slope be?
Negative 7 over 2.
So every line has exactly how many slopes? Yeah, so that was a big picture from yesterday. Every single line has one slope. I picked these 2 because they're, perfectly nice even numbers. But if I knew all the fractions of what these 2 were, I'd get the exact same slope. So it doesn't matter which 2 points I pick on here, I always get the same slope. Okay, slope is a direction thing. So you can see this line. It's going in the same direction the whole time, which means the slope is not going to change at all. If it was like the stock market going up and down, well, that's different slopes, and those are going up and down. But as long as you have one straight line, that means you have one slope. Okay. On the back, we did give you the points. So 1, 1, 3, 4. And you can find the slope there. Go up 3 and right 2. So we have a slope of 3 over 2. But don't stop there. Continue it. I want the graph to go through the line to go through an entire graph. So go up another 3 and over 2 and up another 3 and go over 2. And you can also go back to the beginning and go down 3, 1, 2, 3, over 2. How come this works? And how come these line up perfectly if I'm going down and left instead of up and right? Okay. So down 3 would be negative 3, left 3 would be negative 2, and negative 3 over negative 2 is the same as positive 3 over positive 2. That's why they all line up perfectly. Every time. So your last step was to use a straight edge and draw a perfectly straight line all the way through, showing all the points line up perfectly. And if there is one point that was off, you would have to erase it, go back, figure out what was wrong, and do it again. You'll never just go here and then do this and go back. Okay, if you have one slope, that means this line has to be one direction only and will not change. Okay. And the technical issue I mentioned yesterday is that every time you graph a line, you should use a straight edge, no exceptions ever. If anything, in order to graph, if you don't have a straight edge, you can use the paper itself, fold it over, and now you do have a straight edge. So there's absolute zero excuse for not having exact, straight, perfect lines. Okay, a student ID card or something like that might be easier, or just fold a piece of paper a few times. Use the side of another pencil. You can just grab a pencil if you have another one and use that as a straight. So it doesn't have to be a ruler. You're not measuring how long it is. It just has to be a straight surface to make a straight line with. So really, are you going to give me 0 because I don't have straight lines? Yes. That's what's expected of everybody in the entire planet when they graph, including you. So when you hear this, it doesn't mean it's an option or if you feel like it or if you get around to it. It's absolutely for you and everybody else that takes algebra and any math class. Just absolute straight, perfect lines every time. Okay? High expectations, high standards. So make sure you follow them. Don't make your life more difficult. And of course, if you didn't use a straight edge this time, don't just go back over it. Like, I shouldn't see something like this and then a straight line going through it. Same thing, make it neat. Erase it, make it, do it right the way it should be done right the first time. Okay. Again, how you present your work, people will judge you. So present it neatly, clean, organized. We got to a few other of these. Let's do like 15, graph -6, -1. So we went down to here. And then you had to decide, do I want to go either down 2 and right 5? Or do you want to go up 2 and left 5? Meaning, do you want to put this negative on the top or do you want to put it on the bottom? You have your choice. So which one do you want to do?
One on the left.
One on the left. Yeah, if you do the one on the right, if you go up to left 5, you go off the graph. That's a good sign not to go that direction. So yeah, go down 2 and left 5. Down 2, left 5. And of course, it should line up perfectly. If it doesn't, if it's off just by a little, maybe you counted one square off by accident. Don't accept, well, that's close enough. It should be exact every time. Okay. Down 5. I'm down 2, left 5. Only a straight edge. And you can see your answer is correct. You know it's correct because they all line up. Okay. So yeah, if the negative is in the front, you can apply it to the top or the bottom, but not both. If you put it on the top and bottom, it's now a positive slope because 2 negatives will make a positive. So it's one or the other, not both. All right, going down to, I think we did 17 together yesterday. Yep. But just to reiterate, start at 0, -9, and if you try to go down 7 and right 1, remember if there's no run, it's automatically a positive 1 underneath. You can't go down 7 or right 1. Once again, from elementary school, you have to know that if you move it to the bottom, it's the same exact number. So 7 over -1 is equivalent to -7 over 1. They both equal -7. So you can go up 7, left 1, up 7, left 1, and that's the same thing. Okay. Lastly, I told you to don't worry about these, we'll do them together. This is a mental exercise, and there are some typos here, so it's a little confusing, but just try to get the gist of what we're going after right here. If you're at 4, 4, and you go, use this slope here, if you go up 1 and right 3, what point is that?
That's 5, 7. 3 4s and afterwards in the left.
If I go up 1, what changes from 4, 4, what changes?
It's 5. It's 5 1. 5 7.
If you go up 1, is the x changing or the y changing? The y is changing.
What?
You changed to 5.
Wait, shouldn't it be 5 of those? It's going up.
Yeah, so going up 1 changes the y value, right? This is why it's a good mental exercise. If you do this on the graph, it's very easy. You can just see the numbers and you know where it's at. But I want you to see that the top number changes the y values, the bottom number changes the x values. So if I go up 1, the y value goes up by 1. If I go right 3, that means the x value goes up by 3. So if I went up 1, right 3, that means I'm at 7, 5. So write that in. Okay. Working off. Put everything on there.
Are they all typos or is it just that?
Number 21, same idea. If we start at 5, 1, okay, and I'm going to go up 1 because it's positive, so it's up. Right 2 because it's positive. Up 1, right 2. What point does that take me to? Where does that take you to? 7, 7, 2? Yeah. So going up 1, you'll go from 1 to 2, and going right 2, you'll go from 5 to 7. Very good. So yeah, 7, 2.
Are they all typos?
Lastly, again, you have to decide, well, if I'm at 0, 0, and I want to go to negative 8, something, so that'd be like over here. Should I put the negative on the top or the bottom? Do I want the y to go down or do I want the x to go down?
The X.
You want the x to go down, so make sure you use a slope of 3 over negative 4. So if I go, that'd be up 3, left 4, right? Positive 3 is up, negative 4 is left. So up 3, left 4, that'll take us to where?
-4 and 3.
So if I went up 3 from 0, you're now at the y is 3. And if you're at 0 and you go left 4, you'll be at negative 4. And then just do that again. Up 3, left 4 will put you at
And -8 and 6.
negative 8 and 6. Because I went up 3, so 3 plus 3 is 6. And then left 4, negative 4 minus 4, negative 8. Okay? But a lot of it had to do with, well, you have to know to put it on, not on the top. If you put it on the top, you'll go down 3 and right 4, which is going the opposite direction where negative 8 is. So A good mental exercise, and just to see that the top number here controls the y values. It's weird because it's the first number we talk about, but it's the second number on the coordinate. Okay, it's like that thing we had last week where yes, it touches more than one point, so therefore no, it's not a function. You have to get everything calibrated and in order, so when you're thinking about it, you're thinking about it correctly. All right, again, very simple if you have a graph though, but you don't always have a graph. Okay, so let's switch over to your notes. Here's where we're going to be looking at again, what does it mean to graph these lines? Okay, there's two parts. We looked at it yesterday a little bit. Let's refresh your memory. There's two parts. We had the slope that changes how steep the line is. Whereas negative is going down, and when it gets closer to 0, you can see it becomes more horizontal. When it's positive, it's going up. Okay, but there's also the question about, well, do we always have to start at 0? Okay, meaning if you, in a real life situation, well, yeah, maybe you're making $10 an hour, but maybe you're starting with $50. You already have $50. So you wouldn't want to start at 0. So depending on where your situation is beginning, okay, it changes what we call the y-intercept, where it touches the y-axis, or where x equals 0 is another way of looking at it. Okay. So between these two values, we can graph anything. Anything but what kind of line? Undefined vertical line. That we can never graph. No matter what numbers we pick, that will never be absolutely vertical. Okay. So we're going to do a bunch of real life situations and graph it and plot it and see how things work, and then get you started on your homework. Alright. So here's where we're going to begin. And you can kind of just look at this and get the hang of it and see how I'm coming up with values. And then I'm going to have you jot down a few things. You can see that this is the initial starting place, so I call this my 0. That's my beginning. After one change or one iteration, after 2 iterations, after 3, the first change, second change, third change. But we begin with just 1. Okay, we had 1 open circle. That's the beginning. And then what changed from the beginning to the first step? Added 2. And what went from the first step to the second step? What happened? Okay, added 2 more. And to the third step, added 2 more. So you can see the change was to add 2 more each time. So whatever's changing or adding each time, that's your slope. That's the rate of change. They're one and the same thing. Okay. Another way of looking at it is, at the beginning, x, y, we only have 1 circle. So at the very beginning, at 0, before we even start, we have 1 circle. After the first one, how many circles total? 3. After the second one, we have how many? 4 plus 1 is 5. And after 3, we have 7 total. Okay. If I went ahead and plotted these, we have 0, 1, 1, 3, 2, 5. And you can see, well, that lines up in a nice straight line. How come it's a straight line? It's because we're adding 2 exactly every time. We're not changing how much we add. If we change how much we add every time, this would be more zigzaggy. But since we're staying the same each time, it lines up in a nice straight line. And you can see here, okay, the starting point is 1, and you can see where it crosses right at 1. And the slope is 2, or 2 over 1, and you can see you can go up 2 over 1, up 2 over 1. So it all lines up perfectly. Okay, all lines up perfectly. So it's about seeing here what stays the same. No matter what, that 1 is always the same. So we started at 1. What's changing? Every time we added 2 more. So that's the rate of change. Okay. What's the starting point here? How much are we beginning with? Yeah, how many are right here? There's 2. So we're starting with 2. How much are we adding each time? 1. From here to here we add 1. From here to here, add 1 more. Add 1 more. So we're adding 1x, adding 1 more each time. If we try to, again, plot this, at the beginning, we begin at 0. There were 2. After the first one, there are now 3. After the second one, there are now 4. And if we went ahead and plotted these, started at 2, 1 comma 3, 2 comma 4, you can see a pattern. See that pattern. Okay. And you can see, oh yeah, the y-intercept, the starting place is positive 2, there it is. And the rate of change is 1, which is the same as 1 over 1. So up 1 over 1, up 1 over 1, yeah, it works. So the pictures match with the graph, which match with the equation. All 3 have to agree with one another. Okay. Let's have you guys try one. Okay. Go ahead and write that out. Just sketch a graph and write an equation. You don't have to write down all the squares, but go through the process, check with someone around you, and see what you end up with. Okay? Yeah, most of you walking around, you see that we started off with 3. Okay? So that's the beginning. We added 3 more each time. So 3x, and if we went to graph that, start at 3 and go up 3 over 1. Okay, and it actually goes off the graph. We can't get the rest, but does it work? Yeah, after the first change, we now have 6 squares total. 1, 2, 3, 4, 5, 6. So the graph agrees with the picture, agrees with the equation. All 3 have to make sense. Okay. Should make that bigger. Okay. Now let's get to the good stuff. Here's where the thinking begins. Yep. Real life stuff. Now we got the mechanics down. Let's talk about real life. Now these may not be as obvious as the other ones, but you got lots of tools. One of those is just a T-chart. What are the units? We got 2 units. We have dollars and we have hours. Which one would be the X? Which one would be the Y? Yeah. So X is usually always time. If there's some time involved, days, weeks, months, years, hours, that's always on the X-axis. Money is pretty much always on the Y-axis. And what other context clue gives that away? Bigger numbers here, so it makes sense that would be the money. Okay, so T-chart. After 1 hour, how much money has been made? $10. All right. 1 comma 10. So maybe we don't know the equation right away, but at least I can still figure out how to make the graph, and maybe from the graph I can get the equation. So what else we got? We have after 2 hours, how much money?
20.
All right, so 2 hours, we have $20. And after 3, 30, and you can see a pattern. And math is all about patterns, so we can predict like, oh, this will just keep on going. Of course, you'll be using a straight edge. And then you can read it. After 5 hours, oh yeah, I have $50. After 6 hours, yes, I have $60. Now, so what is the rate of change here?
$10.
Yeah, so it's going up by 10 each time. So your slope is 10. That's what it's increasing by each time. That's the same as how many new blocks are added on the next picture. Yeah, we added 2 more, we added 3 more. Same idea. Now, where is this starting from? So if you work this graph backwards, where's across the y-axis? 0, yeah. We started with no money. Okay. Ironically, this is how most of you guys will start out. You'll have no money, and you'll probably be working for minimum wage, $10 an hour. Okay? Well, by the time you guys start working, it's going up very soon. By the time you guys actually start working, minimum wage will be $10 an hour. Okay?
I heard that they're trying to lower it to make it more jobs available. But didn't they raise it?
Nope, it's not happening. Not happening. Guarantee it's not happening.
Alright. Like I said, trying. Not
Never going to happen. Yeah.
Not succeeding, but trying.
Question. You can look it up online. Okay. All right.
Can I take my red bag in here? Bye, Daddy.
Okay, let's try another one. This requires thinking. The hardest part about these is actually thinking. By the way, this is the part where you are writing and taking notes. If you're, again, sitting and watching, don't come and ask later, how come my grade's low? What can I do to raise my grade? How about do more than just sit there? No, there's no extra credit. No, you can't make up a test. You have to just be a student every day. I see a lot of people sitting, staring, that could have much higher grades if you applied yourself. So here's where the thinking comes into play. Again, money is usually on the y-axis. In this case, what would the x-axis be, or the horizontal axis be? Hours again, yeah. Always good to label it. It makes more sense because we can take the words, change it into symbols a lot easier if we know what stands for what. So we have hours here, we have dollars here. So, not a trick question, but not as easy as you might think. After 1 hour, how much has Gabby made? $40. Read it again. Notice how that has nothing to do with math. It has to do with reading comprehension. If you're one that just kind of looks at the glazes over the words and just sees the numbers and say, oh, I see 30 and 10, so I'm going to just pick one. I guess it's 10. That doesn't really work. You have to read everything in context. So she makes $30 a day no matter what, and then $10 for every hour she actually works. So if she works 1 hour, she'll make the $30 plus $10. That's $40. Very important. So you can see the most difficult part about this math problem is not math. It's reading. Slowing down, reading the whole thing, and understanding the question, not just skipping the words and just pulling out the numbers and doing a 50-50 toss-up. Even if you did a 50-50 toss-up, you notice that the answer was not 30 or 10. If you read it, you knew you had to add it up. So after 2 hours, how much will she have made? Yeah, $50, right? So $30 a day no matter what. And then after 2 hours, $10 each hour, that's $20. 30 plus 20 is 50. Requires some thinking, doesn't it? Okay? If you start thinking, oh yeah, she gets $30 an hour, so that's going to be 30 times 2 is 60, and like that's not what it says. You get $30 one time, $30 a day, no matter what, and then you get paid $10 an hour. Is this realistic? Is anything actually like this? Very much so. So like a tow truck, if your car had to be towed, by the time they get there, they charge you $50 just for getting there, and then they one-time fee. Okay, $50 for us to come out, and then it's $1 for every mile we actually tow the car. So very realistic. Doctor, if you go to the doctor, sign in, they're already charging you so much just for having an appointment, and then when you see the doctor, they might say, well, this test, you need this medication, and then you have to do more. So yes, it's realistic for some professions and jobs that, yeah, you have money before you even begin. For you guys, it's weird because you've never been paid like, nobody's ever said like, okay, here's $20 and for every hour you work, I'm gonna give you 10 more. That's probably never happened to you. You've only been paid after how many hours you worked or whatever job you did. But very realistic, lawyer, doctor, tow truck, whatever. Okay. So if you don't know where to begin, again, a T-chart does help an awful lot. Because now you can just plot this. 140. Okay, 1 comma 40. After 1 hour, I get $40. After 2 hours, I get $50. How much do you think you get after 3 hours? Again, following the pattern. How much do we start off with if we go the other direction? Yeah, we started off with $30. So yeah, our beginning, before we even begin working, we get paid $30. And then how much is it changing? Up 10 over 1, up 10 over 1. So yeah, it's changing 10. And since it's changing $10 each hour, that's how we know, well, that's the rate of change. It's what's happening every hour. Another way, can you get that just from the table here? Yeah, from 40 to 50 is plus 10. And if you go one more, it's going to be from 50 to 60, it's plus 10. And that'll be the same all the way down. We can also go backwards. How can we get this y-intercept? If we couldn't get from the problem or the graph, you can go backwards and say 60 to 50, 50 to 40, and 40 to 30, 1 to 0. The starting point is always where the x value or the x-axis value is 0. That's the y-intercept. So wherever this is 0, that's your starting point, 30. All right. Let's keep on going. Let's have you guys try this one out. Again, I highly recommend start off with a T-chart. It gives you the units, minutes, and gallons, and see what you come up with. Okay. Jot a graph down, have a T-chart down, and write an equation. Okay, so from the picture, there we go. From the here, we can see that, well, after 1 minute, there are 50 gallons left. So 1 minute, 50 gallons. After 2 minutes, there are 40 gallons. 2 minutes, 40 gallons. And you can start to project. After 3 minutes, there'll be 30 gallons. 4 minutes, there'll be 20 gallons. 5 minutes, there'll be 10 gallons. And after 6 minutes, it's empty. Okay, empty. If we go the other direction, what do we start at? 60. So our starting place, again, that should be actually a capital J. That's a brand name. Okay. Should be 60. And the rate of change, as we mentioned earlier, it's going down 10, right 1. Negative 10 over 1 is negative 10x. A follow-up question that you'll be seeing later on these is, well, how many minutes will it take to empty, that kind of thing. On the homework, you actually want to write this switched around a little bit. We usually write it as y equals mx plus b. So So we usually put the slope and everything first, so it would look like this, negative 10x plus 60. We actually start with this number when we're working, but it's actually at the end of your equation. The starting place is usually at the end of the equation. So to read this properly, after you do this an awful lot, you stop thinking, okay, negative 10x plus 60, but you think, okay, I'm starting at 60, I go down by 10. Down, starting here, I go down or up depending on whatever number this is. Okay. And again, we could get it here. Okay, that goes down by 10. That goes down by 10. We can go the other direction, up by 10. And we know 0, 60 is the starting point. Okay, yeah, we're running low on time, so I want to skip to here that you can see without a word problem, how do we do this? Identify the starting point. That's your y-intercept. Crosses the y-axis, -1, and then just like yesterday, the slope, you have to go up 3 and right 1, +1. So your slope is 3 over 1. So we don't have to write 3 over 1. We can just write 3x minus 1, and that's all you'd have to write. Y equals 3x minus 1. So two things. What's the slope? Same as yesterday, but also you have to put at the end, where's it starting? And that's just wherever it crosses the y-axis. Okay. There are a few special cases you have to think about. Where is this starting right here? Where does it cross the y-axis?
0.
At 0. Now, what is the rate of change? So the rate of change is 1 over 1x. So if we write this out, we would write y equals 1x plus 0. But you guys know we normally don't write 1x. We just write x. And we usually don't write plus 0 either. So the correct, fully simplified way to write this answer would be just y equals x. Which means you have to understand that in reverse. If you see y equals x and you're asked to graph that, you have to know that means y equals 1 over 1x plus 0. You have to know to start at 0 and go up 1 over 1. Without any numbers being here, you have to gather all that information. What's the starting point here? Where's it across the y-axis? 3. The slope, is it going up or down? No, it's just 0. So if we put this in the right form, it'd be y equals 0x plus 3. But again, we don't write 0x. We don't write it at all because 0 is a coefficient. You just write y equals 3. So if you see the equation y equals 3, you have to know, like, okay, there's no x here. Oh, that's because the slope is 0. That means it's a horizontal line. So just by looking at this, y equals a number, you know it's a horizontal line, 0 slope. Okay. Again, the vertical lines are the weird ones. They're a little bit different. It's not a function. It doesn't follow all the same rules. So when it's a vertical line, we know the rate of change is undefined, the slope is undefined, and it doesn't go through the y-axis. So we don't have a starting place like, oh, it crossed at 3, it crossed at 0. It doesn't cross at all. So we have to use x. Where is it across the x-axis? Right here. What number is that? Yeah, just x equals 2 is the equation. But as I mentioned at the beginning, everything is weird about vertical lines. It's not y equals, it's undefined slope, it's not a function, has x equals. Okay. Let's get your homework out, give you a look at it. Okay, from the beginning. slope-intercept form. That's the y equals mx plus b. So the slope is always m, the y-intercept is always b. So if you plug this in, you'd have y equals negative 1/4 x plus 0, but again, you leave the 0 part off. You don't need to include that. So little tiny technical things are important. And if you didn't write any of that on your notes, you have to hopefully remember everything. Kind of difficult. Okay. Here, same thing as yesterday. Okay, pick any 2 points, find the slope. So we have to go, what, down how many? Down 1, 2, 3, and right 2. So negative 3 over 2. But now you have to include the y-intercept. Where is it across the y-axis? At what number? Positive 5. So b equals 5. And then you can write your equation. Y equals negative 3 over 2. And that's where you put the x after the slope. And then plus 5. So that's the completed equation right there. So same thing as yesterday, except you have to get the y-intercept and then put it in the right form. Okay. And now there's going to have, like, here's that horizontal line. I hope you took notes so you know how to do a horizontal line. If you didn't, okay, well, get it from somebody else. Okay. You already know the signs of all these. This is positive, that's positive. You know that slope. Okay. So use everything you've learned up to this point to help you finish this up. On the back are the problems that did before. Again, make T-charts to help you do this. He starts at 1,000 feet. Okay, before you begin, you're at 1,000 feet. At least you know where you're starting from and what happens from there. Make a T-chart to help you out. Okay? All right, good luck.